All right. Good afternoon, class, or whatever day it should be. We are moving on to 3.6, the equations of parallel and perpendicular lines. So note, we've kind of done this a little bit in our previous section on 3.5, but now we're getting more in depth on creating the equations for parallel and perpendicular lines. And some of you are already familiar with this anyway due to Algebra 1 if you took it in the past. So this should be a nice review if you've already done so. So from here I have working with a partner. You may work with a partner, but the whole point of notes is that you just copy them down and try to understand what's going on. Otherwise, you know where to find me for help. And so this time it says using a graphing calculator. I am not going to use a calculator, but there's always shortcuts to using it. But let's just say you don't have one. This will help do it your own way. So it says, how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? So at this point we have one point that's given, and then we have an equation of a line. And so we need to find out what is the equation of our other line. So for A, I have here that my point is 0, 2, and I have a line that says y equals 3 over 2x minus 1. And so I note these are parallel lines. They are parallel, and with parallel, they have the same slope. So parallel lines have the same slopes. This should make it a little easier. So I would go through the parallel lines first, then I'll go over the perpendicular lines. So I know for a fact that I have y equals 3 over 2x minus 1. And then I note that my other line, it has to be y equals 3 over 2x. However, I do not know what the b is, and b stands for your y-intercept. So from there, what am I going to do with this point? I note that this is x and y. I'm going to actually plug them in to my y equals mx plus b. However, I'm going to plug in my new m, so the m that is for your parallel or for your perpendicular line. So let's plug in y. So I have 2 equals m, and m is 3 over 2. X is 0, and plus b. So I'm solving for b at this point. So 0 times any number is just 0, so b equals 2. And I note that I know b equals 2 because it's y-intercept and it has to be on that y-axis. So I have y equals 3 over 2x plus 2. Okay? So I'm going to do the same thing with C and D, and I'll go back through B, D, and F for perpendicular lines. So from here, my first equation is given to me. I have y equals 1/2 x plus 2, and though we're doing parallel lines that have the same slope, so I know my new equation is y equals 1/2 x. Again, I don't know what my plus b is, and if it's hard to see, like here, you can always plug it in to solve for b, or you can always counter your new equation. So I know that down here I have a point, so I can plug it in. So I have y equals my mx plus b. But m I know is 1/2 because I know it has to be parallel. My y is -2, and my b is, or my x is 2, and I'm solving for b. So I know that 2 times 1/2 is really 2 over 2, which is just 1. So this is the same thing, 2 over 2. So I have -2 equals 1 plus b. I subtract 1 from both sides. So I have -3 equals b. And I can always count. If you can kind of tell in here, I can count down 1, 2, and 3 is my y-intercept. So y equals 1/2 x minus 3 is my parallel line that passes through this point. Okay? I will do the same for E. And again, I'm giving you both patterns just so if it's hard to see the graph, or if it just gives you a point and you cannot graph it. So I have y is -2x plus 2, and though we're talking about parallel lines, so I know it's going to have the same exact slope. So I have -2x, but again, I don't know what that y-intercept is. So this time I'm going to go backwards. This time I can actually count where my point is. So that is -2, but it wouldn't hurt to plug it back in. So I have x and y, and so I'm going to plug it in. Y is -2, and my new m is -2, x is 0 plus b. Any number times 0 is 0, so -2 equals b. And so I confirmed that my y-intercept is -2. minus 2. Okay, so those are parallel lines. So we're going to go back up and we're going to do perpendicular lines this time. So perpendicular lines are either, you can say reverse, I've said reverse, or you can say opposite, I've said that in other ones, reciprocal. And so that means we're going to take our slope, we're going to take the opposite of it. So if it was positive, it is now negative. Or if it was negative, it's now positive. Then reciprocal means I'm going to flip it if it was a fraction or a whole number. So I will take, this is 3 over 2. So if I want to find the perpendicular slope to my new line that passes through this point, first thing I'm going to do, if it's positive, it's now negative. So I'm negative 3 over 2, and then I take the reciprocal part, and so now reciprocal means to flip. I'm going to flip it, so then I have 2 over negative 3. I know you have a negative 3 at the bottom, that's still the same as negative 2 over 3. So my new slope I know is negative 2 over 3. So my first part, I know I have y equals 3 over 2x minus 1. And then I know my new perpendicular slope is going to be a negative 2/3 x. And again, I'm not sure what the b is or my y-intercept. I can count. Pardon the bell. Again, I'm after school. So continuing on, I need to find my y-intercept or my b. And at this point, I can just look at the graph. I know it is +1 because it's on the y-intercept and it crosses at 0, 1. So I know it's +1. Again, you can always plug in the new one. So my point is 0, 1. So y equals mx plus b. Y is 1. And again, put in my new slope, negative 2/3. X is 0. Plus b. 0 times any number is 1, so I know 1 equals b. And so that's how I know it's my y-intercept there. So let's try it for d. D, y equals 1/2 x plus 2. Now I need to find the reverse or the opposite reciprocal. So I have 1/2, and if it's positive, it's now negative. So I have a negative 1/2. And then I'm going to flip it. So now I have a negative 2 over 1. Any number over 1 is technically a whole number, so it is negative 2. Okay, negative 2. So now I have y equals a negative 2x. Again, I can count. I believe that is +1, but let's say I'm not sure. Let's use the point that's given. So I will take my y equals mx plus b. Y is negative 3. And I take my new slope for m, negative 2. Times x is 2 plus b. We're solving for b, your y-intercept. So I have negative 3 minus 4 plus b. If I add 4 to both sides, I know that 1 equals b. And we can kind of tell right here, but again, if you can't tell on the graph, it always helps to do the equation. So I have y equals negative 2x plus 1. Okay, now let's say I'm not sure if they're perpendicular. Another thing to know about perpendicular is the product of the same slope, and we talked about that in 2.5. So if I were to take both of my slopes, negative 2 over 1, so here, that's the same saying, negative 2 over 1. Any number over 1 is this whole number itself, and I times it by 1/2. I have negative 2 over 2, which is negative 1. So that's how I know my slopes are perpendicular. Okay? So that's just a good check mark to verify if your answer is right. So let's do the same with f. So f, I have y equals negative 2x plus 2. Okay? And so again, reverse reciprocal. We kind of did this here. We know that negative 2x, the reverse reciprocal or opposite reciprocal, is 1/2. But let's say we didn't, so I have negative 2, turn it into a fraction. Negative 2 over 1. Then if it's positive, it's now negative, or negative now positive. So if this was negative, my new one is now positive. Then I'm going to flip it. So now it's 1 over 2. So my new slope is 1/2 x. And again, I do not know what my y-intercept is. It's going to be passing through this point. So it looks like it's a negative 2, but it doesn't hurt to double check. So have x and y, plug it into your y equals mx plus b. So y is 0. and m, our new m is 1/2, and then x is 4, and I have plus b. Okay, so I have 0 equals 4 over 2 plus b, and note I am running out of room, but that is okay. 4 over 2 does reduce to 2, but then we have to get b by itself, so subtract 2 from both sides, so b equals a -2, which is correct. We do have -2 as our y-intercept. Alrighty, and again, you may pause, but I'm going to keep going so it's not a super long video that you have to watch. So flipping over to the next page, this where you're just reading lines. You don't have to go through this as much as you would like to, but you can always try to look to see if they're the same by taking 2 points. These are kind of small. If you want to, you can always look to see if I'm correct. Always check to see if I'm correct. So I have y equals 2x plus 3, and I have one that says 2x minus 2. Okay, and I actually took 2 of these points here to find those answers. And I note the y-intercept where it crosses, 1, 2, 3, and then -2. Same thing for b. I have y equals 1/2 x plus 2, and y equals -2x minus 3. Okay, and again, note by slope or your y-intercept. Okay, awesome, awesome. So we'll go that more in depth in class. However, 3, it says, how can you write the equation of a line that is parallel or perpendicular to a given line passes through a given slope? So for parallel lines, the slopes are the same. Okay? And then for perpendicular, you're taking the opposite or reverse reciprocal. Okay? So in order to find b or y-intercept, okay, you will substitute the slope of your new line in your standard form in y equals mx plus b and solve for b. Okay? Awesome, awesome. Number 4 says, write an equation of a line that is A parallel and B perpendicular to the line y equals 3x plus 2, and it passes through the point 1, -2. So let's start with A. And A is talking about parallel, and I'm going to put that symbol here, which means parallel lines. So I have y equals 3x plus 2, okay? And I know that m is, or my new m is going to be 3 because we're talking about parallel, and parallel have the same slopes. Slopes are the same. So I know that much. So for my y equals mx plus b, I'm going to substitute my new points in. So I will take x and y is -2, and my new slope is 3 times 1 plus b. And when I do that, I have -2 equals 3 plus b. And when I subtract 3 from both sides, b equals a -5. Okay, so the equation of my new line that's parallel and passes through this point is y equals 3x, and my b, or my y-intercept, is -5, so it's y equals 3x minus 5. Okay, so that is for A. So now let's try it for B, which asks for perpendicular. And then perpendicular is this symbol. We talked about that. So again, I have y equals 3x plus 2. But my new m is going to be -1/3. Remember, we took the reverse reciprocal, so that means we take 3, turn it into a fraction. 3 over 1 is still the same thing. Then when it's positive, it's now negative, so I have -3 over 1, and then I flip it, so I have -1 over 3. So that's how I get -1/3. So I'll take my y equals mx plus b and plug in my 1, negative 2. So I have negative 2 equals my new slope times x plus b, and I'm going to solve for b. And when I do that, I'm going to move up here. I have negative 2 equals negative 1/3 plus b. I'm going to add 1/3 for both sides. And again, you can use a calculator for this, or you can solve it by hand with a common denominator. But when I do this, I end up with b equaling negative 5/3. Try to keep fractions with fractions and decimals with decimals. So if I have a fraction here, I don't want to put a decimal here. It gets a little confusing. So keep it with fractions. So now my new equation is y equals my new slope, which is negative 1/3 x minus 5/3, because that's my y-intercept. Okay? Awesome, awesome, awesome. So flip over to the next page. Alright, so I have some vocabulary here. I have slope-intercept form. Slope-intercept form is y equals mx plus b. Okay, where m is your slope. Okay, m is just slope. And y is your y-intercept. So in y equals mx plus b, b is your y-intercept. And it falls on the y-axis. Y-axis, so it would be up and down. Okay? Alright, alright. So I'm going to go on to the next page. We'll do some examples here, and I might upload those later. But in the meantime, we are going to stick with just our vocabulary. So flip over to the next page. I have some extra practice. So I have 1 is 3, negative 2, and y equals 2/3 x minus 1. So this side is asking for a check that they are parallel. So we're doing parallel lines on this page. So let's talk about P. So let's go ahead and draw this graph. Okay, and so it says I have P at 3, negative 2. So I'm going 1, 2, 3, and down 2. Okay, and that's P. And then I have y equals 2/3 x minus 1. So let's start off our y-intercept, which is negative 1. And then I'm going to go up 2 and over 3. And I know it's increasing, so it has to go up this way. So I have a 1, 2, going over 1, 2, 3. Up 1, 2, over 1, 2, 3. I can always go down. Okay. All right. So now I'm going to take this point, and remember we're talking about parallel, so my new slope will still be 2/3, and I'm going to plug in 3, negative 2 into my standard form. So I have y is negative 2 equals 2/3 times 3 plus b, and you're solving for b. So I have negative 2 equals 2. The 3's cancel out, plus b. And when I subtract 2 from both sides, b equals negative 4. So my new equation is y equals 2/3 x minus 4. So I'm going to graph that new line. So I have 1, 2, 3, 4, negative. And I'm going to keep my same slope. 1, 2, 1, 2, 3. Oh, look, it does pass through point P. But 1, 2, 1, 2, 3, 1, 2, 3. So are these lines parallel? They look so to me. They don't cross at any point. All right, all right. So let's move on to the next one. I have number 6, or number 2, where I have 6, 0. And this time I have a distribution problem. So let's go ahead and distribute this one in. So I have y equals negative 2x minus 4. 1, 2, 3, 4. And P is 6, 0. So I'm going over 1, 2, 3, 4, 5, 6 is P. So let's graph this one. So again, I am decreasing. So I'm going to go up 2 over 1, up 2 over 1, or down 2 over 1. All right. Okay, so it passes through point P and has to be parallel. So I know that my new M will still be -2, and I'm going to plug in my new equation. So I have Y, which is 0, equals -2, and my X is 6, plus B, and I'm solving for B. So I have 0 equals -12 plus B, and so B actually equals a positive 12 when I move it over. I don't necessarily have enough room, and that's okay, but I do know it's going to pass somewhere up here with my Y-intercept. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, so I'm going to skip, now I'm not going to skip, I'm going to do number 3. So number 3 says X equals 4. So think of when you have X equals 4, think about every possible point, but X will always have to equal 4. So I can have 4, 0, 4, 2, 4, 3, 4, 4, 4, 5, and so that means the whole time, 1, 2, 3, 4, any point that I have, 4 will always be the X value. So that means my slope is undefined. My slope is undefined here. But again, we're parallel. So my P is -5, 6. So I have 1, 2, 3, 4, 5, going down 6. 1, 2, 3, 4, 5, 6. But again, it has to be parallel. So it means it's going up and down. Because if I were to go this way, it's going to touch it. And that's definitely not parallel. So I'm only going to be focused on the X value here. So those are my parallel lines. Now this one, I'm not going to graph it for you, but note you have to solve for Y, because this is in standard form and you want it in slope-intercept form. And when I do that, I'm going to move everything over. So I have 4Y equals -3X plus 8. I'm going to divide by 4 on each part, not just one of them, for all of it. So then my new equation is Y equals -3 over 4X, and the 8 over 4 reduces to a positive 2. So that is your equation that you will have, and you'll do the same thing you've done for others. Okay, so this one you got to solve for Y in order to get it in slope-intercept form. Okay. Alrighty. So going on to the back page. Now we're talking about perpendicular lines. So for perpendicular lines, remember we're talking about the opposite reciprocal. So opposite or reverse reciprocal. Okay, so my new M will be -1/2, and I know that because I start off with 2, and I'm going to either flip it or do the opposite. So I have 2 over 1. It's positive, so now it becomes -2 over 1. And then I'm going to flip it, so it's -1/2. So -1/2 is my new slope. Then I'm going to plug in my point into my Y equals mx plus b. So Y is 2 equals -1/2, our new slope, times x, which is -2. Or we can say -2 over 1 because we're dealing with fractions, plus b. And so when I do that, I end up with 2 equals 1. Negative times negative is positive. 2 over 2 is 1, plus b. And when I subtract 1, b equals 1. Okay, so my new equation is Y equals -1/2 x plus 1. So let's graph them to see if they're actually perpendicular to each other. So, okay, so P is at negative 2, 2. And our original equation is y equals 2x plus 3, so I have 1, 2, 3. And I'm going to go up 2 over 1. Again, it's not drawn to scale, and that's okay. And so from P, well, I know this is a plus 1, so I know I'm starting here. And let's see if it passes through. So we got negative, so remember it's negative, so we're going decreasing, we're going downward. So I have over 1, 2, up 1. It does pass through point P. So it does recreate my 90-degree angle. Okay? Alrighty, so let's start with 6. So 6, I have x equals 8. So this is similar to the one that we talked about, x equals 8. Whoops, I'm going to move this over. This is my y-axis. And then it's okay to use whiteout to erase lines and pen. That is okay. It's only because I have x equals 8 and I need more room. So I have 1, 2, 3, 4, 5, 6, 7, 8. X equals 8. So remember that has the undefined slope. It's going up and down. And then it says I have a point P where it's 3. So 1, 2, 3, and negative 1. Okay, but this time it's perpendicular, and if you paid attention to some points in class, when you have if you have perpendicular slope or need to find it, and you have an undefined slope. Undefined slopes, perpendicular partner is the zero slope, and zero slope go horizontally, and undefined slope go up and down. So this time I'm only going to look at the y. So this time I'm going across, so I can make that 90-degree angle. Okay, so for 7, this is fairly similar. However, we have to distribute and we have to move this 2 over to the other side because we want y by itself. So in order to do that, let's distribute first. I have y plus 2 equals negative 1/2 x minus 5 over 2. And then I have to subtract 2 from both sides. But remember, this time I'm subtracting 2 only to my like term, not to my 1/2 x. So then I will end up with y equals negative 1/2 x minus 9 over 2. And 9 over 2, negative 9 over 2 is the same as negative 4.5 if you type it in your calculator and want to graph it. If we're finding the new slope for my perpendicular line is a positive 2. Okay, so let's see if you can graph that one. Then for number 8, same thing, I have this in standard form. Anything like this is called standard form, and you need to turn it into slope-intercept form, which is the y equals mx plus b. So I need to move that 4x on the other side. So when I subtract 4x on both sides, y equals negative 4x plus 5. Okay? And if I take the perpendicular partner of this negative 4, it should be a positive 1/4. So let's see if you can graph that one on your own. And that will complete my notes. Until next time, try to practice as much as you can. And I hope you guys have a wonderful weekend. Thank you.